question would be just to stop one. The mediator might be a bottleneck for scaling up if the data is handled, the query responses are passed through the mediator or passed directly to the client with the mediator. Sure.
It might be bottleneck. We have to carefully think about how to realize that. Okay.
Next chance for questions is in the coffee break, but before the coffee break, you will have 15 minutes to present your work. And if it's not enough, talk to him, he is the reason. Yeah.
But this is what the first time Felix is presenting. He's a totally fresh, new PhD student, as the others are too. And he's going into the direction of how to do Polystore, and will give a short introduction of what he did.
You're robbing more of my precious minutes.
Yes.
Go on. So, I would like to talk about cloud polystores, to give a quick overview, a very quick overview now, and talk about open research questions. And as Norbert already outlined the possibilities and advantage of polyglot persistent systems, I want to go a step back and talk about use cases just to motivate it a little bit. So I think I will just go with that one. E-commerce systems were mentioned just now, maybe like Amazon, or if more German example, the Otto Group and the Otto Online Handel. They deal with different kinds of requirements for the website. So the main thing basically is availability. So if the website isn't available at any time, then the Amazon group obviously loses money, so availability means money. Regarding consistency, we can differentiate a little bit, so we can talk about full consistency maybe on the checkout. If the customer wants to buy stuff, then it has to be consistent in the way, so the Amazon group doesn't lose money, or any other seller. But regarding something like ratings or reviews or stock information, a little bit delay is okay, or can be okay, and we don't need full consistency for that. If we have thousands of users concurrently on the website, we need something like high read throughput when we're querying for the results, so the customers can shop without delay. And obviously, if we talk about e-commerce, we also have to talk about analytics, because every seller or platform owner wants to do some kind of analysis, like market basket analysis or stock analysis or something like that. And we could talk about other use cases like simulation, decision systems, or medical data management system, a quite popular example in the world of polyglot persistence. But I will short that out. So what I want to conclude on all these use cases, or similar use cases, is that we have a wide array of diverse requirements, and no system can handle all these requirements very well. So some system may be very good at high throughput, write throughput, like a Redis, because it's in memory, but a Mongo not so good. So the question is, how do the application developer handle this obviously requirement problem? Well, obviously they try to look at the cloud and big data landscape, and they are bombarded with a wider range of different applications which are good at something, but not so good at other things. Maybe if we want to do analytics and visualization, Tableau may be very good, but when you talk about business intelligence, then SAP and Oracle Hyperion may be your data store of choice. And all these multiple data stores have to do integrated manually, and that is that we need to have some special knowledge about the desired data store that we want to integrate. We have to do the orchestration, administration for ourselves. And we must be experienced with the technology too, so we can use the different sweet spots of these stores. And obviously, if we implement that, it's mostly static and non-adaptive. So if the requirements change, then we have to change the underlying system itself. So, to sum up, it's easy to get lost in all this. There is no one-size-fits-all solution. We have the standards, and obviously, this graphic is from 2012, so the landscape is very different now, and it keeps evolving, and it's hard to keep up. So, one way to solve this could be to integrate multiple data models into one system, something like ArrangoDB does with graph, key value, and document store in one store. Or we order them by domain-specific objects, and something like David. It stands for Digital Audiovisual Integrated Database, which is mainly used to analyze gestures, if I recall correctly. But obviously these systems have the problem that we don't leverage the sweet spots of specified data stores. So that's not sufficient too. The other solution would be to introduce a mediate layer, something that Norbert called maybe polyglot persistence manager or mediator, something like that. And this layer is the orchestrator for managing multiple data stores underneath. And that obviously creates overhead. And the based on our working group's work on REST, backend, ValiDB, and database as a service, the interesting question that stems from there is, can the performance of a system like database as a backend as a service be further enhanced despite the additional overhead? And to approach this question, we looked at different classes of systems which such an intermediate layer. Looked at systems that already exist, and looked which properties these systems provide and which problems they try to solve. So, first there are two variants with an intermediate layer where the underlying data stores are homogeneous, just for completeness reasons. So we talk about federated database systems if we have a single query interface, and if we have multiple query interfaces, we talk about polyglot or polylingual, like we like to call it to make it more clear what is happening here with the query interface database system. That can be something like multibase on the federated database side, or Spark SQL on the polyglot database system side. But the interesting architectures we want to look at are the architectures where we have heterogeneous data stores underneath, because we want to leverage the different properties of different data stores. So, and these are then called multi-stores if we have a single query interface, and polystores if we have multiple query interfaces. So, now that the stage is set and we know what we're talking about in this context about the architectures, let's talk about problems and challenges. And regarding that, there's quite a bunch. For example, we could ask how to decide where to store the incoming data. Or we could ask how to do the query planning and processing, which query interface to provide and how many, how to design the schema and optimize it if we have one, how to provide for the functionality of the underlying system so we don't lose the properties of the system itself, how to handle schema evolution, how to realize extendability, how to communicate between the stores, adaptability, you know where this is going. We can talk about all these questions in long detail, and then we are talking about that at the end of the week still. So we focus on a selected set of questions that we might consider most important for this for now, especially regarding our focus on the backend as a service. So, all right, then export systems. 5 minutes. All right, we have five systems explored. You may notice one is grayed out. That's for a reason, because based on our knowledge, PolyFiniDB is a vision paper and not an implemented system. Maybe Heiko will illuminate us on that. Maybe they are far further on that. But the focus will be on these 5 systems: SQL++, Cloud MySQL, Estocada, Polybase, and BigDog. They all have different design objectives. For example, SQL++ is originally a query language, but is also implemented, but aims to do work over different data models, and is implemented by a database. I think AsterisDB has it. Yeah, I will show you that. So let's get to the comparison. we had two foci. The first one was to view it from a query side, so the side of the user of these systems, and the one that is coming in the next slide was focusing on the system side. Okay. So first of all, we wanted to look at the schema modeling over multiple data models if an explicit schema was given. And all these systems omit this question quite good. So the only system which in any way mentions something like schema modeling is Big Dog, and that not in a explicit API or query language, but in a so-called Big Dog cast operator, which is incorporated in the query language, but that's not quite elegant. If we talk about query language, then the most systems have one single query language. In the case of SQL++ and Cloud MDSQL, it's quite obvious, it's query languages with the system underneath. Estocada uses some kind of query block tree based on the system ARP query block trees cross-model, that is the XM stands for. Right? And one remark to the Cloud MDSQL, they are also incorporating Python code in their queries. It can be quite ugly, but in sample works. Polybase is a system by Microsoft that wants to link the Hadoop. It wants to link an Hadoop cluster to the Microsoft SQL relational database management system, and they're using Transact SQL. Big Dog has multiple query language, something like SQL, array functional language, D4L with SQL, and Polyphony wants, based on our knowledge, wants to incorporate SQL, Cypher, and Crete. Okay, the most interesting ones. Write operations only talked about in Polybase environment. The other environments only talk about querying. The most query optimization is cost-based. The only exception is Big Dog, which uses a heuristic with benchmarking query plans and then deciding on that, but I think that should be done here. Query execution is an interesting point because how do we deal with all these queries, and how do we mediate the queries to the different stores? So mostly it's query splitting. We have some kind of bind join that's basically joining over multiple results. And we have something here that is data shipping, that is basically ad hoc migration of data or results to stores that are more suitable for executing a specific task. Okay, and I want to talk about that swiftly. So Norbert talked about adaptability and topology. So the system is in an optimal way, it's able to adapt its topology to tackle different requirements and demands. So that's an important part, and only system that is able to do that is the Polybase, but only because the Hadoop does it for itself. So not the system itself. Then we have something like migration and automatic replication partitioning, where it's mainly mediation, which is only tackled by Polybase in some extent, and Polyphony wants to do it. Logging recovery is not done at all, so I will skip that. That is basically the data models that are incorporated. You can read it up later. So, sum it up. We have a wide variety of use cases with diverse persistency requirements. Obviously, we have no one-fits-all solution. We have multiple ways of implementing that intermediate layer. We have a handful of solutions, so we looked at 5 very quickly, and we have one that is in the next talk, that is PolyphonyDB. The solutions that we looked at are very rudimentary. They are tailored for a very specific use case, and they are very static and not adaptable. And we see a need for intelligent and feature-rich Polystores, so we come to the conclusion. That is my last slide. No worries. The system, from our point of view, like Norbert already mentioned, the system has to be able to adapt to its data store topology to provide an optimal ecosystem for the requirements that the system is facing. We need to route the data to the optimal data store in an intelligent manner. That's the mediation part based on the user requirements, so that's something like SLAs. and based on user behavior queries. So if we query one attribute very often with a write operation, then maybe it's better suited on a Redis, something like that. Then we have to deal with some kind of live migration to adapt to the changing topology. So if the topology is changing and we want to adapt to meet current requirements, we obviously have to migrate the data to the sufficient data stores, and that is a hard problem because data is slow. And the last one, the cloud is very good for orchestrating all this adaptive topology because of its flexible nature, and that is something we want to use in our backend as a service architecture. And that is basically the research focus of me and my two colleagues. So if we have some time for questions, I would be pleased to discuss with you, or otherwise during
This is my part.
All right.
Thank you. Will be available. And
Not a question, more comment. Mediation is always very difficult. I would fear the overhead because if I, as an application, need mediation and I implement it myself, it's much better to have a proven service in between. So I would fear it.
Now, the question is, milliseconds count.
Yeah.
These scenarios.
Yeah, so if I don't need it, the component should be optional.
Yeah,
if I need mediation, it goes out of my way.
Yeah, but we spend
Yeah,
not effort to make it really scalable with the caching and all these things, and making really efficient. And the question is there a way to make the overall thing even more efficient if we do mediation? So, up to which extent does it make sense to spend that additional overhead for mediation in such a context, where you only don't want to lose one thing, and to find out is exactly this. Is that possible? Is this actually and you see the three new PhD students who currently try to find their topics in this scenario, but I think there's a lot to do. So the closest approach is the Polystores approach.
So it will be interesting to talk more on this in the coffee break and to think about what Heiko will tell us about the many classes of his system. So let's talk about Polystores outside in the break and resume here at 11 o'clock. And thank you to the presenters. Ja, das ist